All right, I am going to try to do multiple screen sharing to show you some PowerPoint questions and just kind of give an overview of what was covered in class today in 9.10. So this was my opening question in class, and it gives a third degree Taylor polynomial, and it wants to know what the value is of the third derivative of f at 4. So if you want to pause and try it on your own, you can, if you don't want me to give away the answer. But I am going to write the answer on the screen. So I'm going to see if I'm going to give me some patience here. I got to mess around and see if this will work. I think I can do this. Okay. So here's how you want to go about this. With the way we build a Taylor polynomial is we take the derivative, the level of the derivative, so we do first derivative, second derivative, third derivative at that value, times the x minus the center at that level, again, first power, second power, third power, divided by that factorial. So I'm talking about the third derivative, so that means I'm talking about the term that has the third power. So here's my focus. I know that the way I build my coefficient is I take the derivative level at that number and I divide it by that level factorial. And when I do that, if I look at this one right here, I see that I have a coefficient of 1 over 512. So that tells me that you can almost think of it as setting up like proportion, that the third derivative of 4 divided by 3 factorial must give me 1 over 512. So 3 factorial is 6, so I can multiply by 6 on both sides to get rid of that. So I end up with 6 over 512, which reduces to 3 over 256, and that is D. So I want to show you that one. I also want to show you, give me a second to get out of this. I got to move my screen around a lot here. I want to get a blank screen so I can tell you a little other things that we did today. So we started talking more about the big three. So the three most common Taylor series that essentially everything on the AP test will be kind of built from. So here they are, E, sine, and cosine. Things to help you remember, sine is an odd function and it has all the odd powers and odd factorials. Cosine is an even function and has all the even powers and even factorials. So the idea is that I can use this to build other Taylor series that are similar, kind of build off of this. So what I mean by that is, let's say I wanted to build a Taylor series for e to the x squared over 2. I can take this series for e and I can replace my x with this new power and I can build that series. So that series would be 1 plus, instead of x, we would put x squared over 2. Plus, instead of x squared, we would do x squared over 2 being squared over 2 factorial. And then plus x squared over 2 to the third over 3 factorial, and so on. I can even do it for, this is called the general term. I can even do it for the general term. If I put an x squared over 2 in for x, say that whole thing is to the n over n factorial, that would be, we call it the general term of this Taylor series. So you have this great way to kind of manipulate a series based on kind of combining it with something that you already know. Another one that I've seen a lot is you can multiply something by a Taylor series. So if I wanted to write a Taylor series approximation for x times e to the x, I could take all the terms in e to the x and multiply it by an extra x. So my terms would be x plus now an x squared plus now an x to the third over 2 factorial plus an x to the fourth over 3 factorial, And my general term would be an extra x times x to the n over n factorial, or in other words, x to the n plus 1 over n factorial. And other things that I could do with it, kind of showing you all the extensions here. Since these are all written as power series, which means they are a function of x, they have an x value in it, we can, since they're a function, we can actually derive them. We can integrate them. So you might see something that says, let's call f the series that represents x e to the x, and then it will ask you to then derive f. So I could take the terms that I just found and I could derive each one, and that would give me an f prime. Or I could even take the derivative of the general term. So if that is my function, if I wanted to derive it, the derivative, you would do a power rule. The power is n plus 1. Power out front, power 1 less. We end up with n plus 1 times x to the power 1 less would be the n over n factorial. When you take a derivative, it's only in terms of x's. So the only thing that is impacted with your derivative when you derive is you just focus on your x's. Your n's are essentially like coefficients. So you'll notice like I still have an n factorial in the bottom when I derive. I still use things like n powers when I derive. So it is just doing a power rule. So you will have questions that will ask you to not only build series from this basic list of 3, kind of just looking here, but it'll also ask you to then derive from that or to even integrate from it. You can really manipulate in a lot of different ways. So I have one on the PowerPoint. Let me find it. I think it was on this one. Yeah. Let me show you this one. So this is one that we also talked about today, and it gives us a power series. So you have 1 minus x squared over 3 factorial plus x to the 4th over 5 factorial and so on. And it wanted to know essentially what function does this represent? It says converges to what function? In other words, what function would this series be representing? Again, if you don't want to know my answer, pause it, try it on your own. Here goes. First thing you'll notice is it does alternate in signs. So it goes positive, negative, which means that it's not going to be an e function because our e functions remain constant all the time. What I have here, though, is I have a alternating, so it's either sine or cosine, but you'll notice that my powers of x doesn't match up with my factorials. It's actually one less. So like, for example, in this term, I don't know if it's going to let me write on it or not. I think I can. In this term, we have a 3 factorial, but we don't have an x to the 3rd. We have one less power of x. Same thing with the next one. We have one less power of x. What it did is this is actually the sine series. However, we have divided out an x from every term. So this answer here is C. If you think about what sine looks like, again, looking at that basic list, one of the big 3, and then you reduce each one by x, you would get the series there. So that's the way they're going to ask these questions. That's the way they're going to kind of check in your ability to like manipulate these things. Let me see if I had any other ones here that I wanted to look at. Oh yeah, I wanted to do this one. This is one I did in class today. Again, if you can want to look over it and try it on your own, and then restart the video so you can hear my answer. So this wants you to write the coefficient of x to the 6th when you use this Taylor series. So a couple things with this. When I presented this one this morning, the first comment was, oh my God, I have to go out to all the way to the 6th power. Yes and no, you do, but you're going to get there a whole lot faster than you realize. So if you think about what your e to the x looks like. So you've got a 1, you've got an x, you've got an x squared over 2 factorial, you've got an x to the 3rd over 3 factorial. Here's why I don't have to go out as far as I might realize. I'm going to replace the x's in that series with 3x squared. When I put a 3x squared in for x and then I take it to another power, I'm going to get to x to the 6th a lot sooner than I realize. I am actually going to be looking at this term. The fact that it's divided by 2, I'm just going to put that 1/2 out front. So I am going to have a 1/2 out front. I am going to take, instead of x to the 3rd, I'm going to take 3x squared to the 3rd and then over 3 factorial. So I'm manipulating this term in my e to the x power series. I'm replacing it with 3x squared. I'm replacing the x with 3x squared. When I do that and multiply it out, I do get an x to the 6th power. I get 27x to the 6th power over 2 times 3 factorial 6. 2 times 6 is 12. That will reduce. They each reduce by a factor of 3. That reduces to 9 over 4. And my correct answer is C, 9 over 4. So that is another way that they manipulate. I will say E is probably the most commonly asked question. I just feel like it shows up a ton. So let me show you. Let's see. I did this one in class today. So let me mention this one. Hold on. So I did this one in class today. This one was not using one of the big 3, but kind of making you build it yourself. So again, if you want to try it and kind of wait and see if you did it right by listening to me, go ahead. So this one, you will have to derive it. You don't have to derive it that much, though. You're going to rewrite it as 1 minus x to the negative 2 power. So the way that we derive it is we're going to do a chain rule. So power out front, power 1 less, Derivative of what's inside is so easy to forget. You actually have a negative derivative. So my derivative ends up being positive 2 over 1 minus x to the third. So when I put, so it's a Maclaurin series, which means it's centered at 0. When I put 0 into the original function, I get 1. So my first term is 1, not x, so E is wrong. I actually don't have to go too much further than the next term, because if I put 0 into the next term, I get a coefficient of 2. So my next term should have a positive 2 coefficient. And if you look at these, A is missing the 2 and it's negative. B doesn't even have an x term. It skips it. D, excuse me. B and C both have a 2x, but one's negative and one's positive. So without doing any more work, I know the answer is C. And I kind of like that because it allows us to get an answer without doing a ton of work. I'll show you one more thing that I did today. So we talked about how this was an example that I had students work on, but it is here. I just wanted to kind of talk through it. How to, again, build a Maclaurin polynomial by taking something that you know and kind of adding to it. So this was one that we did in the class. The idea is I want to write a Maclaurin approximation for the first 4 terms of the derivative, where your function is x squared e to the x. So first thing I would do, and a lot of times on the AP test, they'll kind of lead you there. They will tell you, write out the first so many terms of e to the x. So that's kind of our given information. We know e to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial. Then what we're going to do is we're going to multiply every one of those terms by an x squared. So you'll notice the next line is now taking every term that was above it and multiplying by an x squared. Now the directions say I want you to write a derivative of that. So now the derivative is just power up front, power 1 less. I went further. I kind of got on a roll when I was typing this years ago. It wanted the first 4 terms of the derivative. I went a little further, so you do not need this term, but this is what they would be looking for to get full credit on an AP test. So that's what we did in class. It was not a very long day. I really wanted to spend time just looking at AP examples, kind of putting this all together. Kind of the expectation of where we're headed. The next class, there will be a review over the 3 topics that are on this next quiz. So the 3 topics are power series, Taylor polynomials, and Taylor series. Then you'll have an AP classroom review assignment from that. Then we will do an in-class review where we'll go through several problems on a PowerPoint, some AP problems. I can post those things online. And then we will have the 2-part quiz. Day 1 outside of class will be a Flipgrid will be listed and a Delta Math assignment. And the day 2 in class will be a Google form. So that is where we are. If you have been out and you feel like you're missing out, I wanted to make sure you kind of got a quick overview of what we've been doing in class.